Pluto's classification might get revised again. In 1930, a famous Disney cartoon character named Pluto made its debut. Coincidentally, that same year, astronomer Clyde Tombaugh made a significant discovery in the solar system, a celestial object that would later be named Pluto. Some argue that the animated dog was named after the newly found planet to capitalize on its popularity, but the true reason remains uncertain. What is certain is that both Pluto, the character, and Pluto, the small planet, have continued to captivate astronomers and the public alike since their respective discoveries. From the start, astronomers faced difficulties in classifying Pluto. The question of whether it should be considered a planet or dwarf planet has persisted over the years. Recently, the discovery of one of Pluto's moons, Charon, has once again sparked discussions about its classification. Some propose that the Pluto-Charon system should be classified as a binary dwarf planet system. This classification would recognize the interconnected nature of the two bodies, emphasizing their shared characteristics and dynamics. But it's not that easy. Pluto. So back in 1930, big things were happening in the field of astronomy. They were making all kinds of advancements and discovering some pretty cool stuff. One of the most interesting finds happened at the Lowell Observatory in Arizona. They noticed this little dot of light that ended up being the 9th planet in our solar system, Pluto. Before we get into all the details, we have to give a shout out to Percival Lowell. He was a really smart astronomer who spent his whole life studying the outer parts of our solar system. He noticed that Uranus and Neptune had these weird orbits, and he thought it was because of another planet out there. Lowell did a ton of observations and calculations and came up with the idea of a 9th planet, which he called Planet X. Even though Lowell died in 1916, other astronomers at the Lowell Observatory carried on his work. This is where Clyde Tombaugh comes in. He was a regular guy from Kansas who loved looking at the stars. In 1929, he got a job at the Lowell Observatory taking pictures of the night sky. His job was to carefully compare the images and see if anything was moving out there. It was a lot of work with lots of late nights and close examination of these pictures. But after almost a year, Tombaugh hit the jackpot on February 18, 1930. There, in a couple of pictures he took in January, he saw this little dot that had moved from its original spot. That little dot was our friend Pluto, finally discovered. Now, even though everyone was excited about finding the 9th planet, some scientists weren't sure if Pluto really fit in the same group as the big gas planets. It was pretty tiny and had a weird orbit. This debate went on for a long time until finally in 2006, they decided to call Pluto a dwarf planet instead. Before that, nobody had ever heard of a dwarf planet. What was that? An official definition was required, a definition to distinguish between a planet and a dwarf one. Dwarf planet definition. As of today, a dwarf planet is a celestial body orbiting the Sun that has enough mass to be spherical in shape and that has not cleared the neighborhood around its orbit. The last condition, in short, sets an upper boundary to the gravitational pull of a dwarf planet. Think of a massive object as a vacuum cleaner that is able to devoid its surroundings of anything that crosses its path. The more massive an object is, the more it will attract smaller objects, and the more it will clear out its neighborhood. So yeah, taking this as a definition, astronomers had to officially recognize at least 4 more dwarf planets in the solar system: Eris, Ceres, Makemake, and Haumea. Several dozen more are being considered for the category, and scientists estimate that hundreds or even thousands of dwarf planets may exist in the solar system. Dwarf planets can, in principle, be orbited around by their own moons. Pluto, for instance, has 5 of them: Nix, Hydra, Styx, Kerberos, and Charon. Among these, Charon is the one we are most interested in. Let me give you a glimpse of it. Charon. The honor of discovering Charon falls to Dr. James Christie, an astronomer at the United States Naval Observatory. In June of 1978, while conducting observations of Pluto, Christie noticed a peculiar elongation in the planet's shape. That was Charon. The revelation of this moon's existence brought about a fundamental shift in our understanding of Pluto's true nature. Charon is a substantial moon with a diameter roughly half that of Pluto. The size relationship is unparalleled in our solar system, and this is one of the main reasons why astronomers might want to reconsider the classification of this system. It turns out that Charon has a huge canyon system that stretches along its equator. Its total length is at least 1,000 kilometers, and its depth reaches 5.6 miles or 9 kilometers. Just for comparison, the Grand Canyon is only 1 mile deep. This was discovered by NASA's New Horizons mission, a spacecraft that made history with the first close-up exploration of the Pluto system. One of the most significant aspects of Charon's discovery is its impact on the Pluto-Charon system's center of mass, known as the barycenter. This is a point around which a system composed of two objects rotates. If one of the two objects is by far the heaviest, as in the case of the Sun and the Earth, or Jupiter and its moon Io, the barycenter falls directly inside the heaviest object's radius. This means that although the Sun certainly feels the effect of Earth's gravitational pull, its shift along the orbit is kind of negligible compared to how much the Earth moves due to the Sun's pull. The same applies to Jupiter and Io, but this is not always the case. If the two objects have a comparable mass, then the barycenter can fall outside of the most massive body, and both objects can move effectively around that point. This is exactly the case of Pluto and Charon. The barycenter of this system lies outside of Pluto, in the space between them. This unique configuration has far-reaching implications for the orbital dynamics and mutual interactions of these two celestial bodies. In other words, we can confidently say that the Moon orbits the Earth and that Io orbits Jupiter. But while it doesn't seem 100% correct to say that Charon orbits Pluto, or at least it does it in a different way. One thing is certain, if Charon does not properly orbit Pluto, then it's not Pluto's moon. Moreover, Charon orbits around the Sun. It is spherical in shape and it has not cleared its neighborhood. Therefore, it seems to meet all the criteria to be considered a dwarf planet. If that is the case, then the Pluto-Charon system has to be regarded as the first binary dwarf system in the solar system. At this point, a question naturally arises. Is it possible to find binary planet systems anywhere else in the universe? Before moving on to the double planet's existence, be sure to stay tuned afterwards if you haven't seen our earlier release on Was any planet kicked out of the solar system besides Pluto? Double planet's existence. Well, it depends on the labels we give. While the definition of a binary planet system varies, there has yet to be any discovery of two planets revolving around a common center of mass. However, if we broaden the definition of a planet, there are instances where two bodies are much closer in mass. One prominent example is the Earth-Moon system. Although the Moon is not typically considered a planet, its mass is approximately 1/81th that of the Earth, making it the largest satellite relative to the size of its primary. The European Space Agency has even referred to the Earth-Moon system as a double planet. While this system may not fulfill the criteria of a binary system, it highlights the possibility of bodies without similar mass ratios. The Pluto-Charon system, with its mass ratio of about 1:8, closely approximates a binary system. However, due to debates surrounding Pluto's planetary status, this system is now often referred to as a binary dwarf planets system. Nonetheless, it serves as another example of bodies with comparable masses. Additionally, there are binary minor planets such as Antiope, where the two bodies are nearly identical in size. This finding showcases the existence of minor bodies that can be considered binary. While we have not yet discovered binary planets in the strictest sense, the presence of binary-like systems such as the Earth-Moon and Pluto-Charon systems suggests that they may exist elsewhere in the universe. After all, binary star systems are very well known in the universe. It's actually estimated that up to 85% of stars are in binary systems, with some in triple or even higher multiple systems. In these terms, our Sun seems to be one of a kind. However, even though binary stars are very common, double planets are expected to be much rarer because their formation requires specific conditions and a delicate balance of gravitational forces. However, there might be some good news. The recent discovery by the JWST in the Orion Nebula has identified approximately 40 pairs of free-floating gas giant planets. These unique findings, known as Jupiter mass binary objects or jumbos, have surprised scientists as they appear to exist as couples. The intriguing question remains unanswered. Did these jumbos originate from the gas in the Orion Nebula as failed stars, or were they captured from a different planetary system through the gravitational pull of a passing star that disrupted their orbits? Further studies and observations will shed light on this mystery in the next couple of months. Stay tuned. Understanding these systems will contribute to our knowledge of celestial mechanics and the formation of planetary bodies. Was any planet thrown out of the solar system besides Pluto? The 8 worlds of the solar system are placed elegantly in their orbits by the sun's gravitational effects. Though there were only 8 planets formed during the birth of our solar system, were there more planets in our solar system formed? According to our observations of other solar systems, it would have seemed to us that there existed some more planets, some giant ones and others the size of Mars. One giant which probably got kicked out from our solar system. What happened to them and where are they now? Was there possibly a ghost planet in our solar system too? If yes, then where is it now? Why can't we observe it currently? In today's video, we're going to have a brief talk about the ghost planet, the lost giant of our solar system, formation of our solar system, and planets. In the present-day world, most of us would assume that all the matter we see around us, from the massive sun to the tiniest piece of rock, from Saturn's beautiful ring to the white shiny moon, everything we see around us was formed 5 billion years ago, along with the formation of our solar system in the solar nebula. You may not believe it, but the entire mass of our solar system, which we see around, accounted for a mere 0.002% mass of the solar nebula. The rest of the mass was blown away violently when our sun came into existence. All the planets that we see around us began to form about 4.6 billion years ago. Following the formation of the sun, the matter situated away from the sun in the accretion disk also came together, creating clumps of rocks which further underwent more collisions and came together to form planets. However, the planets which we see around us were not the only ones formed. They were the only ones who survived the events following the creation of these planets. Gas giant planets such as Jupiter first assembled a solid core and then captured a massive atmosphere. The inner 4 planets had a lot of molten rocky material available to them, unlike the gas giants. Hence, these planets first formed a molten core, which further collected more cosmic dust and materials to form a large planetary mass. These planets further underwent more collisions, ejecting debris into space. This debris was utilized to create natural satellites like our Moon, which was formed by a collision between our Earth and a planet similar to Mars. Hence, only the best of planets remained while the weak were destroyed. Some material which was left unused was further utilized to form other cosmological objects such as meteors, asteroids, and comets. The universe also follows the principle of survival of the best. Cheers and be proud of yourself. You're one of the best in the universe. All of the material which was left unused for further planetary formation was thrown away into deep space. Some of this material was captured by the sun billions of miles from us, forming the Kuiper Belt and the Oort cloud. At last, 10 major planets and many other dwarfs and planets like Pluto remain standing, suffering though all the chaos of the universe. With time, the planets stabilized themselves into a fixed orbit around the sun. The period of stabilization continued for millions of years in several stages. So, what happened to all other planets, including our giant 9th planet? As we discussed, the universe too follows the Sigma rule, survival of the best. Most of the planets were destroyed via collisions with one another, ejecting a lot of material into outer space. Some of this material accumulated and formed a disk around the sun, which we now know as the asteroid belt. However, some studies conducted by a bunch of brilliant minds amongst astronomers confirm the existence of the ghost planet in our solar system. Introduction to the lost planet. In the year 2011, a team led by David Nesvorny, an astronomer at the Southwest Research Institute, ran a series of simulations while researching about the orbits of planets and the early conditions of our solar system. The research was centralized on the idea of the migration of planets from one stable orbit to another while interacting with nearby cosmic materials, which may increase or decrease the size of the orbit of a planet. The solar system was not always as stable as we see it today. During the unstable area of the solar system, there was a gravitational tug-of-war going on between the 5 outer giant planets, including the ghost giant. This period of instability of the solar system was named as the Nice model instability. We will discuss sometime later in the future about the Nice model instability theory, which is a whole different topic in itself. This theory shook the very foundations of theories on the solar system, making astronomers wonder whether there existed a ninth planet, and also if Neptune and Uranus swapped their respective places in space. Better to discuss this later on in the future. While running their simulations, the astronomers concluded their results by saying that there were 5 outer planets, not 4 of them as we see them now. After several failed attempts, they assumed the mass of the 5th giant to be comparable to that of Uranus, and its orbit was predicted to lie between Uranus and Neptune. Nesvorny also assumed some special conditions to match the end results with our present-day understanding of the solar system. 1. The orbits of the 4 giants were considered to resemble approximately that of their present-day orbits. 2. The final planetary calibration was predicted to have 4 planets left. 3. The third condition was based on the eccentric centers of the 5 planets. Eccentricity is a mathematical term which defines how elliptical, or let us say how ovoid, the orbit of a planet will be. According to the simulations, it seemed that the ejection of the giant occurred approximately 600 million years after the birth of the solar system. That is, during the area of instability of our solar system, much similar to our predictions. The remaining planets then stabilized and migrated to the present orbits we see today. But why was it tossed into deep space far away from our home? Throughout the observations made by him, it was clear to Nesvorny that Jupiter and Saturn had the greatest roles to play in the ejection of the 5th giant from our solar system. To understand how this could happen, we need to know how gravitational kicking from one planet affects the other. We will discuss this term furthermore in this video. Just be patient and believe in us. Now, moving back to the theory, let us consider 2 cosmic bodies. In our case, we will consider one as Jupiter and the other as the lost giant. During early times, when everything was in chaos, Jupiter decided to have some fun. It moved somewhat away from its original orbit around the Sun and went around, wandering and kicking any material coming in its way. We don't literally mean it was having fun. Due to the presence of other materials in our solar nebula, most of the objects were in chaos, changing their orbits, and many more. Jupiter was no exception to that. This caused Jupiter to interact with the giant planet. However, Jupiter wasn't the only one interacting with the giant planet. Other celestial objects such as Saturn and Neptune were also responsible for kicking the giant planet. For the sake of simplicity, let's consider kicking as the violent interaction between 2 celestial bodies, during which they both tried to retain their existing orbits, due to which the more massive planet, being more dominant, pushes the less dominant planet further away in space for the sake of self-stability whenever they come in contact with each other. We are going to use this term furthermore in this video. Now, this is where the plot twists for both Jupiter and the ghost planet. Every time the ghost planet came into contact with Jupiter, Saturn, and the rest of the giants, it experienced gravitational kicking from them, pushing its orbit further away in space from the Sun until one last time, when Jupiter finally kicked it so hard that it never returned as close to the Sun as it used to be. It wasn't really thrown out of the orbit of the Sun, but in an orbit too large to observe. From there on, external interactions of this planet with other stars and the combined gravitational pull of external stars pulled it further away from us, pulling the planet away in silent eternity, forever roaming in deep and silent darkness of the universe, unaffected by all the happenings in the universe. Other examples of planets being flung away out of their solar systems. The ghost planet isn't the only planet in our universe flung miles apart from its hometown, similar to us human beings. Recent discoveries have shown a lot more planets leaving their respective solar systems, with many varying reasons ranging from instability to the distance factor. Some planets' orbits have even been discovered to be larger than the orbit of our Oort cloud, although such cases are rare. The ghost planet was surely a mystery to astronomers, but were we ever less curious whenever it came to fact verifications? As of today's date, we are currently observing thousands of solar systems formations, all thanks to our companions, the Hubble telescope and James Webb telescope. But can we surely say this was all there could be to the lost giant? Was this the only possible reason for the ghost planet to escape our realm of visions? Or was the lost planet ever a part of our solar system? Couldn't it be that the ghost planet was never part of our solar system, instead being an alien wandering planet whose course of motion got changed by its interaction with our solar system? Couldn't it be that the ghost giant is the ninth planet still in orbit around our sun? We'll leave the doubts to you. And of course, don't ever shy away to present your doubts in our comment section. We love to hear from you and reply to all your comments. Also, keep sharing all the love at our channel. It helps us make more interesting topics like this, enhancing both your and our curiosity. Be tuned in for more updates and continue being insanely curious.